The 3-in-1 Smart Car and IoT Learning Kit from SunFounder is a hands-on, all-included electronics kit that is perfect for anyone who wants to learn how to master the Arduino. The kit comes with an Arduino, 22 different sensors and modules, breadboards, jumper wires, and everything else you need to build a bunch of fun and interesting projects. Learn about robotics by building a remote-controlled smart car that can be controlled with an infrared remote controller, or drive on its own and avoid obstacles or follow a line. Learn about the Internet of Things with a project that lets you monitor the temperature, humidity, and light level of a room from an app on your smartphone. And build a plant monitor that tracks the temperature, humidity, light intensity, and soil moisture, and displays it on your smartphone so you can keep your plants watered remotely. It's a super cool kit, and I had lots of fun building all the projects in it. So click the link in the description below to order the kit from SunFounder. Classes in Arduino programming are basically the same thing as libraries. They let you group together functions and variables that serve similar purposes. Think of a class like a template that lets you reuse the same code without having to type it over and over. Classes are templates of code for what are called objects. Objects let you access the functions and variables inside of a class. Let's build a project that blinks 2 LEDs at different rates. This is what the sketch would look like without classes and objects. We declare variables for the LED pins. In this case, it's a red LED and a green LED. Then we set the pin mode for the 2 LEDs in the setup section. In the loop, we digital write the green LED high, delay for 2000 milliseconds, then digital write it low, and delay for another 2000 milliseconds. Then we digital write the red LED high, delay for 1000 milliseconds, then digital write it low, and delay for another 1000 milliseconds. This will make the green LED blink on for 2 seconds, then off for 2 seconds. Then make the red LED blink on for 1 second, then off for 1 second. Let's see how we can do the same thing with classes and objects. In order to make an Arduino class, we need to create 2 files. One file is called the header file. The header file is where the class is declared. It contains a list of all the functions and variables used inside the class. You can name the header file anything you want, but I'm going to call it my class. It needs to have a .h extension. The other file we need is called the source file. The source file will contain the actual code for the functions and defines what should happen when you create an object. It needs to have the same name as the header file, but with a .cpp extension. We'll write the sketch that uses this class later, but now let's start writing the header file. The first piece of code we need is called an include guard. The include guard prevents errors in case the library is accidentally included more than once in the sketch. This is the name of the header file, with an _h added to it. The main code of the file will go in here. Next, we need to include the Arduino.h library. Arduino.h is the core library that contains the Arduino's built-in functions. Including it here makes those functions available for use in this file. Now we can define the class. To define a class, type class, the name of the class, and open and close curly brackets. The name of the class in this example is my class, so I have class, my class. The code for the class goes inside the curly brackets. The functions and variables inside a class can be public or private. The public and private keywords are called access specifiers. Public functions and variables can be used by the programmer inside the sketch. But private functions and variables can only be used inside the class. They can't be used in the sketch. Every class needs a special function called a constructor. The constructor defines what will happen when an object is created. When we write the sketch for this project, we're going to create an object for the green LED and another object for the red LED. The constructor will tell the Arduino what to do when we create those LED objects. We'll write the actual code for the constructor when we define it in the source file. But we still need to declare it here in the header file. Since the objects will be created in the sketch, the constructor declaration needs to be public. The constructor declaration needs to have the same name as the class. I name this class my class, so I'll write my class, open and close parentheses, and a semicolon. Like I said earlier, the constructor is going to tell the Arduino what to do when we create the LED objects. And when we connect LEDs to the Arduino, we have to set the pin modes of the LED pins. So when we write the actual code for the constructor in the source file, we'll need to put the pin mode function inside it. Remember that the pin mode function takes a pin number as the first parameter. So we're going to need to pass that pin number along to the constructor so that the pin mode function can use it. To do that, we need to declare a variable inside the parentheses here. Let's declare an int variable called pin. Now we need to declare the function that's going to make the LED blink. Functions inside classes are declared the same way they're declared in sketches. First, we write the return type. This function isn't going to return any values, so the return type is void. Then we write the name of the function. Let's call it my function. Since this function is going to blink LEDs, it'd be nice to have control over how fast the blinking happens. We can do that by passing a variable to the function that specifies the length of the delays. That way, when we use the function in the sketch, it'll have a parameter that we can use to pass it the length of the delay. Let's declare a variable in here to store that parameter. I'll call it blink rate. So now, whatever argument we put in the parentheses of the function in the sketch, that value will be passed to the function's code in the source file. The function is also going to need to know the pin numbers the LEDs are connected to. So we need to declare a variable to store that pin number. The pin number will be set in the sketch, but it will only be used inside the function. So we can declare it as a private variable. This will make more sense when we see the code for the source file. The convention is to name private variables with an underscore before the variable name. So let's declare this as int underscore pin. Okay, that's all we need for the header file. Now let's write the source file. First, we need to include the Arduino.h library. So this file can use the Arduino's built-in functions like pin mode, digital write, and delay. Then we need to include the header file we just wrote. We do that the same way we include all classes, with a hash include, followed by the name of the header file in quotation marks. Now we can write the constructor definition. This code will be executed every time an object is created. The constructor definition starts with the name of the class, which is my class, followed by 2 colons. The 2 colons are called the scope resolution operator. Then we write the name of the constructor that we declared in the header file. The constructor needs to have the same name as the class. So the constructor's name will be myClass2. When we create objects of this class, they're going to represent the pins for the green LED and the red LED. And we need to set the pin mode of those pins to output each time an object is created. To do that, we're first going to need to pass the pin number to the constructor. We can do that by putting the declaration for the pin variable inside the parentheses here. Now let's write the actual code for the constructor. All we have to do is set the pin mode, so we use the pin mode function. The pin number will be passed to the constructor when the object is created. So we use the pin variable here. And the mode will be set to output. Now, remember we declared a private variable in the header file called _pin. We're going to set that equal to the public pin variable. What that's going to do is set the private _pin variable equal to the public pin variable we're using here. We'll see why we want to do that in a minute. But now, let's write the function that's going to make the LEDs blink. To define the function, we first need to write the return type of the function. This function isn't going to return any values, so its type is void. To define a function, we first need to write the name of the class to which the function belongs. Then we need the scope resolution operator. Then we need the name of the function. We already declared the function in the header file. Here, we're defining the function we named myFunction. This function is going to have a parameter for the duration of the LED blinks. We said earlier that we're going to store that value in the blink rate variable. So we need to declare the blink rate variable inside the parentheses here. This will make the function have a parameter. So when we use it in the sketch, we can pass it an argument. In this function, that argument will be the blink rate. Now we can write the code that will make the LEDs blink. It's the same code we usually use to blink LEDs. Now we're going to use that private pin variable for the pin. And write it high. Up here, we set the private pin variable equal to the public pin variable. So when we create the LED object, the pin number will be stored in the public pin variable and passed to the constructor. Then, the same pin number will be stored in the private pin variable and be passed on to the digital write function. Now we delay. The delay duration will be set in the sketch and stored in the blink rate variable. So we put blink rate in here. Then we digital write to the private pin variable again. But this time we write it low. And then we delay again by the blink rate. Okay, that's all we need for the source file. Now let's write the sketch. Classes are treated just like libraries. So we can include our class the same way we include libraries. We just put #include with the name of the header file inside the angle brackets. Now let's make this sketch blink 2 LEDs, a red one and a green one. To use the functions in a class, you first need to make an object. Then you use the object to access the functions. We want to blink 2 LEDs, so we're going to need to create 2 objects. One for the red LED and one for the green LED. To create an object, first you type the name of the class. The name of our class is myClass, so I'll put that here. Then you type the name of the object. You can name objects whatever you want, but it's best to make them descriptive. So let's call the first one red LED. Now, remember when we made the constructor? We defined it so that the public pin variable will be passed to it. We can put the pin number as an argument in the object, and that pin number will be passed to the constructor. We'll connect the red LED to pin 10, so I'll put 10 in here. Pin 10 will be passed to the constructor. And that will send pin 10 to the pin mode function. Now we can create another object for the green LED. Let's connect the green LED to pin 11. So now pin 11 will be passed to the constructor and will be set as an output by the pin mode function. Normally we would set the pin mode in the setup section, but we've taken care of that already in the constructor, so we can leave it empty. Now we can write the loop section. So at this point we have 2 objects, red LED and green LED. And we want to blink both of them with our myFunction function, which we defined in the source file. To use functions from a class or library, you have to create an object first. We've already done that with our green LED and red LED objects. Then you need to write the name of the object you want to use the function on. Let's apply myFunction to the green LED object first. We start by writing the name of the object. Then a period. Then the name of the function we want to call. We want to use the myFunction function, so I'll put that here. So this will call the myFunction function from our class and apply it to the green LED object. Now, remember when we defined the function, we said we wanted to pass the blink rate to it to control how fast the LED blinks. So we can put a number in here, and that will be passed on to the delay function we put in the myFunction function. Let's delay the blinks by 2000 milliseconds. Now we just need to call the same function on the red LED object. So the name of the object goes first, then a period, then the name of the function. Let's blink the red LED for 1000 milliseconds. So now you can see that we're using the same function on two different LEDs. And that's the beauty of using objects. You can use the same functions on multiple objects. This makes your code simpler, more efficient, and easier for others to use as well. Now, before we can upload this sketch to the Arduino, we need to put our header and source files in the Arduino libraries folder. Create a new folder with the same name as the class. We called our class myClass, so I'll call it myClass. Then put the header and source files in the folder. Okay, now we can upload the sketch. So here's the red LED connected to pin 10 with a current limiting resistor. And the green LED connected to pin 11 with the current limiting resistor. The red LED flashes on for 1 second, then off for 1 second. Then the green LED flashes on for 2 seconds, then off for 2 seconds. You might not find a need to write your own classes or libraries, but knowing how to create objects is very useful for the Arduino. In the next section, we're going to switch gears and start learning about some of the hardware devices you can connect to the Arduino. SunFounder is my go-to source for sensors, modules, and other parts for the Arduino and Raspberry Pi. They have a huge selection of STEM, robotics, and IoT kits, and lots of useful sensors and modules. Every product has an online tutorial with wiring diagrams and example code. They also offer free shipping on all orders, with no minimum. Give them a try at www.sunfounder.com next time you need to order some parts.